So chemistry 11.4, some of you are grading 11.3s, but it's very much the same. But from the 11.4 life, the new law is Charles, so C-H-A-R-L-E-S, and then an apostrophe S that sometimes gets controversial in English circles, how to do possessives of names that ends with S's. Directly is the second blank. Kelvin temperature is the third blank, but I would take temperature for a day, but Kelvin temperature is by far your better answer there. Directly means if one thing goes up, the other thing also goes up. Or if one goes down, the other goes down. They go in the same direction. 4 is 0. 5 is to add 273. And then we branch off into old stuff. Question about new stuff. So 5 characteristics that we've been doing for a while are expansion, fills all of the space in which it's placed, indefinite shape and volume, fits a vessel, fits any vessel, compressibility, a large volume can fit into a pressurized tank, low density, grams per liter instead of grams per milliliter like solids and liquids do, and then mixing. 3 things is heat and motion are related. The particles of all matter are in motion to some degree, and heat is an indication of that motion. The 5 assumptions are gas is composed of molecules, most of the volume is empty space, there's no attractive forces of molecules, there's constant rapid motion of molecules. We want to get 3 of molecules on there, and that's like a half point kind of thing each time now. There's perfectly elastic collisions, which means there's no kinetic energy lost. The average kinetic energy is proportional to Kelvin temperature. The gases that conform are ideal, the other gases are real. The 2 circumstances are low pressure or low temperature, high pressure. And pressure is force per unit area. What causes it is collisions of molecules. The instrument is the barometer. And then there's 8 ways to do the standard pressure, so pick 6 of 760 torr, 760 mmHg, 76 cmHg, 14.7 psi, 1 atm, 1.013 times 10 to the 5th, big P, little a for pascals, 29.9 inches of Hg for mercury, 1013 MBAR for millibars. Then the 2 things is altitude and moisture. Then if it's 11.4, it's at the bottom. Of 11.3, it's at the top. It's Boyle's law. It's inversely. And if you're having an 11.4 quiz, it's P1V1 equals P2V2. Question about trying to score anything up? In a minute, we'll look at the homework, which stretches from 8 to 11. Before we do that, we'll do a little bit of math. Before we do that, we'll do a little bit of just clarity of what the next quiz has. It's time to shrink. Some of these questions we've seen so many days, it's just time to stop doing this every day. So 11.5, I'm going to shrink it to 22 by cutting some stuff. So what's new on 11.5? There's a new person with a new law that's 2 points. Then I'm going to ditch most of those old questions and kick back in on what is pressure, what causes it. That section is still there. So what is pressure, what causes it, still there. Instrument still there. The 8 different ways named 6 still there. 2 things still there. And then the laws are going to be there, but the laws aren't necessarily going to be in order. So it'll be the same blanks in the same spaces, but it might not be Boyle then Charles, it might be Charles then Boyle, so just be on the lookout for me tinkering the order of the laws on those. New question, you will need a new equation for the new law, which is behind me here on the board. That's new equation for new law to run Charles' law. Other things that make the quiz or extra credits someday. When it says at 0 Kelvin, the volume of a gas in theory is 0, there's a reason why this is theoretical. If you have a gas and you try to cool it down to 0 Kelvin, Why is that just not gonna work? It's gonna turn into a liquid, and eventually liquids tend to turn into solids. You can't maintain that gas forever. So this is a theoretical thing. It's also real difficult to reach absolute zero. That's also not super practical to get something to that temperature. But someday for the test, if you say for this in theory zero thing, that's theoretical because you get solids or liquids first. That's a bonus point sprinkled your way someday. Converting temperature, if you like to work from equations, Celsius is equal to Kelvin. Anybody know how that would go the rest of the way? Minus 273. Or if you want to go Kelvin equals Celsius plus 273. If you like memorizing equations, that won't let you down. I don't tend to do it that way. I tend to just reason this out on the moment. Kelvin temperatures can't ever be negatives. If you subtract, you take the risk that you might turn out something negative. So if you're making Kelvin, don't do that by subtracting. If you're ever making a Kelvin temperature, do it by adding. If you're trying to get away from Kelvin temperature, do it by subtracting. 273 being the magic number, but that's going to be useful tonight in some of the problems. If you do say for the test, another bonus thing, if you remember it's there around this add 273 question, if you mention absolute zero, you mention that that's 0 kelvins, and you mention that that's negative 273 degrees Celsius, I'd give you a point for that bundle. The other thing I'd give you a point for on the test is that Fahrenheit equals, anybody remember this in regards to Celsius? Anybody know that one?
Plus 32
There is a plus 32.
times 9 over 5.
9 over 5 would work. I'm going to go 1.8, but 9 over 5 is equivalent to that. So Fahrenheit is 1.8 Celsius plus 32. You have a program for that.
No,
Or you just remembered? I wasn't sure you had your calculator. I thought maybe you were doing a program PXE or something to find the formula out of it. That's a programmable thing. So that's our stuff. So 11.5, 2 new points. I keep everything from what is pressure down, but basically, and the top also stays. And I may have tinkered with the order. Question about 11.5? Okay, next homework up involves the math that's behind me. So if you want to join me on page 285, that's where I'll be in about 30 seconds. The homework that's going to grow out of the math I'm about to do, that's due tomorrow, is a 1H and a 12 to 15. So 12 to 15 is the main problems, but there's also a 1H. Don't forget about the 1H. So off we go. 285 says we have a volume of 4.50 liters. So here's the equation I'm working today. Volume 1 on top of volume 2 equals temperature 1 on top of temperature 2. So they say 4.50 liters. I'm going to fill that in for volume 1. They say 27 degrees Celsius. I'm not going to fill in 27 right here for temperature 1. Why am I not going to fill in 27 for temperature 1? It has to be Kelvin temperature. So if they give you a Celsius temperature, you have to make a Kelvin temperature. This equation only works with Kelvin temperatures. So I think this is here because I believe there's one question late in the chapter where they give you a Fahrenheit thing and you have to maybe convert to or from Fahrenheit or something. But it has to be Kelvin temperature if you're working this equation. So if I give you 27 Celsius, you're going to go 27 plus 273 makes 300. Then it says volume is going to be 6 liters. So I'm going to stick 6 on volume 2, and then I need to solve for this. Question about how the numbers are there. And then what's your algebra skill going to do you? Maybe, maybe not. Maybe, maybe not. Anybody have a different algebra approach, fraction equals fraction, algebra approach?
Let's multiply.
Most people are going to be most comfortable cross multiplying. I'm not saying what you're doing is not right, but if the variable's on the bottom especially, I think more comfort will be found for more people by cross multiplying. 4.5 goes with x, 6 multiplies 300, and then we're looking at that after we cross multiply. Then divide. The x is going to be 400, and 400 might be the answer. 400 is a temperature, but it's a temperature measured in Kelvin. So if they ask you what's the temperature, say 400 Kelvin, you're fine. If they say what's the Kelvin temperature, you're fine. But you're not fine if they ask you what is the Celsius temperature. And they ask in this question, what is the Celsius temperature? So adaptation to get to Celsius is subtract 273. You won't always have to do that, that's a maybe. But 127 degrees Celsius is what we're hunting off of that. Super foundational important point is temperatures have to be in Kelvin. Question there. So let's do one more. Upper page to 286, 11.4 says we have a gas. It's 160 milliliters. So 160 milliliters is going to go volume 1. It says 1 ATM. And we just really we can do about 1 ATM. Nothing. Don't care. It's a pressure, so it doesn't matter. 27 degrees Celsius is mentioned. So temperature 1, fill in at 27? No, fill in. Well, why not fill in 27? Because it's not Kelvin. 27 Celsius we need to make. Yeah, it shouldn't be taking this long. The number, why is that? Shouldn't have taken us that long. We just did it like 18 seconds ago. We made this 300 from the same temperature. So 27 was 300, 5 minutes, 2 minutes, 1 minute ago, whatever that was. 27 still is 300 here. No, nothing changed with that. Then they say calculate a new volume. So X marks the spot. New volume when we're 0 Celsius. Well, clearly don't fill in 0 because algebra doesn't let you put zeros on the bottom anyway, but 0 Celsius needs to be 273 Kelvin. Solving for X, I'd again recommend probably to cross multiply. So 300 times X equals a big number in the 30,000s. 300,000s. And then you look to divide, take the big number and divide by the 300. We're hoping that gets you 146 milliliters. Question about those. 27 Celsius adds 273. Any Celsius temperature you're given, you'll have to add 273 to use it. Anybody else something there? Not a great check, but a quick check. The word of the day is no longer inversely. The word today was directly, which means if something goes up, the other thing should go up about the same amount. So if 4.5 went up some to 6, 300 going up some to 400, by percentage basis, that is equivalent. 160 going up to, or going down to 146. Makes sense if 300 goes down to 273. Just make sure on your comparisons the temperatures are always Kelvin. You can't compare that with the Celsius in the same amount. It just doesn't work. Question about the math behind me that you're trying to do 12 to 15, you're trying to do 1 each. Then our last order of business is to see if you need any help with 8 to 11. So before you would give me the 8 to 11, which I have one of them from yesterday that was fine, make sure your 8 to 11 also has 1E, 1F, 1G, 2B, 2C, 2D. Make sure the scraps of letters are on there before you turn it. So if you need a minute, take a minute and get those letter scraps on there. But 8 to 11 is the name of the game today. Does anybody need any guidance to do the 8 to 11s? Yeah. Which, 11? Okay, so 11, your first main issue is you can't have liters in the same question as milliliters. Do you see how that's in there that way? They have a 10.1 liter,
Yeah,
and then they have a 500 milliliter.
yeah, I see it.
So our first job is going to get that fixed up. So you could either make the liters into milliliters, or you could make the milliliters into liters. That's really your choice. There's not a right or wrong way to do that. Did you get that far yet? Okay. Do you need help getting liters turned into milliliters or doing that? Okay. So if we have any, I'll do both ways and you can do whatever you want. If they give me liters, I can do dimensional analysis and put anybody in the room, I put liters on the bottom and I put milliliters on the top. They'll give us this number. And then how do we set this up? What's the deal with milliliters versus liters? 1,000 milliliters make a liter. So if you want to change liters into milliliters, you're going to multiply 1,000 with that number. If you don't want to do that, but you instead want to get rid of milliliters, we would do this conversion by putting, with what unit? Milliliters on the bottom, liters on the top, but still the 1,000 goes with milliliters, 1 goes with liters. And in that case, the number that they gave you, you'll divide by 1,000. You okay with that? Just pick one, whichever one you like better, convert that one. Then that's the equation that ruled our life.
Yeah,
Are you okay with that equation once you get it, once you got that conversion? You good?
yeah, okay.
You're welcome. Anybody else, 8 to 11, have anything?
What, stuff from 1 and 2, did you say has to go with this?
With this group, there's a 1 EFG and a 2 BCD.
And
On
for
9.
12 to 15, are there any?
12 to 15 is a 1H.
On 9, how do you convert from force to atmosphere?
Okay. So, torr, if you start with torr, you put torr on the bottom, ATM on the top, and then we know these numbers from the quiz.
Oh,
Your
you just
torr number
use
for the quiz.
Standard measure.
Uh-huh.
Okay, then I'm good, yeah.
Okay. No, let's throw them out there to help other people. Or
760.
760 for torr versus
1.
1 for ATMs.
Okay.
Yeah, just use them off your list of 8.